Topic of this worksheet is slope, and for this specific video, we're going to look at topic 1, which is just different ways to find slope. So when we're talking about slope, we're talking about the slope of a line, and the definition would be the numerical measure of the steepness of a line is called the slope. So we're looking at how steep is our line and what direction our line is going. So we want to have a number that tells us how steep and what direction that line is going. Is the line from left to right rising? Is the line from left to right falling? Okay. So slope compares the vertical change, which we call the rise. So vertical change is the rise. Think up, down. Okay. And it compares it to the horizontal change, so left, right, which we call the run, when going from one fixed point on a line to another. So if we look at this little image right here, so I'm right here, we have this one point on a line compared to this other point on a line. And if we look at these dotted lines right here, that's kind of showing us a vertical change from that first point to the second point. If we just look along the y-axis, what is that change? And then these dotted lines right here, we're looking at from one point to the other, how did that line change according to the x-axis? So what was that horizontal change? And if we can find a ratio of those two things, we can get a numerical measure for the steepness of a line, okay? Frequently, you will hear us talk about slope as rise over run, and that really does help you remember the formula for the slope. So again, the vertical change is going to be your rise. That's kind of the change along the y-axis. The horizontal change, or the change along the x-axis, we call it the run. And ultimately, the formula is going to be rise divided by run. Okay? So the first thing we're going to talk about is just finding slope, looking at different images. Okay? So to calculate the slope, we use a ratio that compares the change in y, that's our vertical change. So vertical change is a change along the y-axis, to the change in the x-axis, which is the horizontal change. So again, we're looking at a change in y compared to a change in x, which is really just a change in the vertical versus a change in the horizontal, okay? And we also denote slope with a lowercase m. So if we're looking for the formula, we already know kind of visually what's happening. If we're looking at a formula, we want to think, okay, m, that is slope, which is rise over run. We know that rise is a change in our y's. We know that run is a change in our x's. So this becomes the formula that we use. As long as you have 2 points on a line, so given 2 points on a line, and we'll call those points x1, y1. Just think of that little subscript of a 1, just saying this is our first point. And x2 comma y2, again, that subscript of 2 just means this is our second point. If we can think of these two as points on a line, the way we would calculate the slope would be to subtract the y's and subtract the x's. Just be consistent. If you're going to start with the second point, you're going to take second y, subtract first y. You're also going to have to take second x and subtract first x. Okay, so we've got it kind of visually. We've got the formula. Now we need to talk about actual examples. Okay. So let's look at example 1. So example 1 says find the slope of each line. So luckily for the first and second image here, we do have specific points on the graph. So we're going to look at those specific points first. But if I look at this point right here for part A, and I compare it to this point on part A, so the first point versus the second point. To go from this first point, I would have to go up until I get to this point, and then I would have to go to the right until I get to this point. So we can see rise over run. And if I just count on this graph, I go from -3 on the y-axis, and I go up 1, 2, 3, 4. That takes me to where the second point is on the y-axis, so my rise is +4. I'm going up 4, so think up for positive. And then from the y-axis to the x-axis, I would have to go to the right 1, 2. So my run is 2. So if I were thinking of the slope, it is rise over run, which we know the rise is the change in the y. So where did I start? Where did I end on the y-axis? And then divide it by the run, which is where did I start and where did I end on the x-axis? I would just get 4 over 2, or 2. So this line has a slope of 2. And again, we would just denote that m equals 2. And because it is a +2, notice that the line is going uphill. So this line rises from left to right. All right. And when a line rises, so that means it's going uphill from left to right, that tells you that you're going to have a positive slope. All right, for our second example, we have a point here and a point here. Okay, so I'm going to start at the leftmost point, and I'm going to figure out how in the world would I get to the rightmost point. So let's talk y-axis, so up and down. So from this point, I would need to go down 1, down 2 to get here. And then from there, I would have to go to the right 1, 2, 3, 4, 5, 6, 7, 8. So let's think about this. The rise, we would have to go down 2, which is -2. The run, we had to go to the right. Let's double check. We had to go from here. We had to go 1, 2, 3, 4, 5, 6, 7, 8. So we had to go to the right 8, which is +8. So my slope is going to be -2 over 8, which is -1/4. So the slope here is -1/4. Notice the slope is negative, and notice this line is going downhill from left to right. So we would say this line falls from left to right. And that's always going to be the case when you have a negative slope. So positive slope indicates that the line is going uphill from left to right. Negative slope indicates that the line is going downhill from left to right. The bigger the number is, or let's say the further away from 0 the number is, the steeper the line is. The closer to 0, the less steep the line is going to be. Okay, now let's go ahead and look at how to use that formula. So remember here, we've got the formula for slope, okay? This is our formula for slope. We take the difference in our y's, we divide it by the difference in our x's. Remember, rise is up and down, that would be the vertical axis. Run is left and right, which would be the horizontal axis, so it's going to be y over x. So let's go down and look at example 2. So example 2 says find the slope of the line that goes through each pair of points, okay? Now, just so we have it on this screen, let me make a little space here. Remember, slope is y2 minus y1 over x2 minus x1. And so for each of these examples, we've been given 2 points that we know are on a line. So I'm going to go ahead and just label the first point x1, y1, x2, y2. It legitimately doesn't matter which point you label 1 and which point you label 2, but when you go to apply the formula, make sure you're consistent. So whatever you start with for the y, you need to start there for the x, okay? So I'm going to take this quite literally with the points I have. So I've got m equals y2 minus y1 over x2 minus x1. This is a formula that you would be expected to memorize, and I find that if I write it down every time I use it, I can memorize it a lot easier. Okay, so every time you use these formulas, write them down until you don't have to look at the formula when you write it down, and you can just write it down from memory. Okay, so I want to take y2, which is 2. I want to subtract y1, which is -1. Watch your signs, okay? And now I need to divide that by x2 minus x1. So 3 minus -2, okay? Now, remember, when you subtract a negative, it really just becomes an addition. So instead of subtracting -1, I can take 2, that first point in the numerator, and I can add the opposite of -1, which is +1. So it really just becomes addition. And then in the denominator, instead of subtracting -2, I can add the opposite of -2, which is +2. So here I would get 3/5. So the slope of the line here is 3/5. And we don't, well, I can maybe make room. Let me make some room and I can kind of show you what this is going to look like. I'm going to rearrange this just a little bit. So we had, this was 2 plus 1 over 3 plus 2, which was 3/5. So our slope is 3/5. But let's just sketch this really quickly and see what this looks like. So let's say we have a y-axis, we have our x-axis, we had the point -2, -1, so something like that. We had the point 3, 2. So our line would be doing something like this. And notice we had a positive slope and we have a line that's going uphill from left to right. Okay, so we weren't asked to graph it, but I think it's nice just to have kind of a visual here. All right, for part B, we have, let's go ahead and label them. So the first point I'm going to say is x1, y1. Second point is x2, y2. And our slope, remember, if you write down the formula, every time you use it, you'll memorize it really quickly. We get y2 minus y1 over x2 minus x1. Well, y2 is -3. Y1 is 2, so I'm going to get -3 minus 2. X1 or x2 is 1, and then x1 is -3, so we've got to be really careful there. We're subtracting a negative again. So let's see, in the numerator, -3 minus 2 is just -5. There's nothing weird there. In the denominator, 1 minus -3 is really 1 plus 3. So this becomes -5 over 4. So our slope for this second line is -5/4. And again, let's just sketch it and see what it's going to look like. So we've got an x-axis. We've got a y-axis. We want to go 1, 2, 3, 1, 2. So we've got a point here. And then 1, 1, 2, 3. We've got a point here. So from left to right, we can see that this line is indeed falling, which makes sense because our slope was negative. Okay. Now let's look at the last two examples. The last two examples are special, so make sure you kind of put a little star beside these two because something weird is going to happen. So just off the bat, you can't see anything weird, but we'll go ahead and label and we'll just go about this like we did the other two examples. So remember, m equals y2 minus y1 over x2 minus x1. Well, y2 is 1, y1 is 1, x2 is 2, x1 is -5. So let's see, in the numerator, we're just going to get 0. 1 minus 1 is 0. The denominator is really 2 plus 7. So we're going to get 0. Oh, 2 plus 7. It's 2 plus 5, y'all, which equals 7. So we get 0 over 7, which is really just 0. Make sure you remember division by 0 is not okay, but you can take 0 and you can divide it by a number. So 0 divided by 7 is just 0. But let's take a look at what's really, really happening here. So we've got our x and our y axis. I'm going to go ahead and connect these with a different color so you can see very clearly. These 2 points have the same exact y coordinate. And we talked about this in a previous video. When you have the same y coordinates, that tells you that you've got a horizontal line. So when your y coordinates are the same, you're going to end up with a 0 in the numerator, which means your slope is 0. Okay, and when you have a 0 slope, that means you have a horizontal line. So m equals 0 always means the line is horizontal. Or you could say all horizontal lines have 0 slope, and make sure you put 0 as the slope. Don't say there's no slope. There is a slope. It just happens to have a value of 0. That means it's not going up or down. It has no steepness to it. It's not rising. It's not falling. It's just flat. Okay. Now for the last example, again, we're going to label x1, y1, x2, y2. We know the formula for slope is y2 minus y1 over x2 minus x1. Again, write it over and over and you'll remember it. So let's see, x2, or rather y2 is -1. We're going to subtract y1, which is 2. x2 is 4. We're going to subtract x1, which is also 4. So let's see, for the numerator, I get -3, but for the denominator, I get 0. And remember, I said it just a second ago, division by 0 can't happen. Okay, so anytime you have a number divided by 0, you have to say that that is undefined. All right, so we have a positive slope, a negative slope, a 0 slope, and now we have an undefined slope. So what do we think that's going to look like? Well, let's draw it. We have our x and our y axis, so we did y first, x second. All right, so for the first point, we go to the right 4, up 2. Second point, we go to the right 4, down 1. And hopefully you can see pretty clearly that we have an undefined slope, which tells us that we have a vertical line. So in this case, m is undefined, means the line is vertical. You could also say all vertical lines have an undefined slope. So it's really important that you understand the definition of the slope. It is also important that you, hold on, let me get my mouse. It's important that you understand the definition of slope. You also need to understand visually what's happening with slope. You need to understand that whole idea of the ratio in the change in your y-axis compared to the change in your x-axis. You definitely need to know the formula, and the best way to learn the formula is write it down every time you use it until you remember it. Know how to find the slope of a line from a graph, and very, very important, know how to find the slope of a line from a formula, and definitely understand what's happening when you have a slope that is 0 versus a slope that is undefined.